All right. So today we're going to start with the second lecture from the module about water and environment. And we're going to talk about the Amazon River. The Amazon River is what we like to call the superlative river because it does go into the major category almost in all the different ways we can measure a river. In fact, in here we express a few of those. Amazon is to the rivers what the Himalayas are to the mountains, or what is the Challenger Deep to the deepest trenches. In fact, 20% of all the river water in the world is flowing in the Amazon River. The salinity and color of the Atlantic Ocean is affected for a long distance, about 320 kilometers from the mouth of the river, and in particular is going, as we see later, we're going to talk about this later, the river is going to the mouth and then move north all the way into the Caribbean, reaching a place and affecting the environment in a great way. So, the Amazon River. A beautiful picture in here representing one of the largest rivers. As we see, very wide, but also what we see here is part of the system. Clouds. A big number of the volume of water going through the river is recycled all the time. In fact, the evaporation is quite large, so evaporate and precipitate again and again, and numbers are close to about 60% of the volume being part of the cycling in a normal time. So, a little history here. The first European to go into the river, and in fact was the one that named it, was Francisco de Orellana in 1541 to 1542. That's the time when he actually went into discovering the Amazon River, discovering for the Western conquistadors, because in fact he found out there was fully inhabited all through the river. The name Amazon or Amazonas is the name given to the tribes that were fighting with them, and he realized that many women were participating in the fight, and hence the name of Amazonas, referring to the Amazon group of Asia and Africa that were described by the Greek historians. The name is Stockholm, is the one we use today. So here we have a graphic from the time representing more or less what they thought they were experiencing here. In particular, they mentioned the Tapuya tribe as having those warrior women in their numbers. Now, if we put all the rivers of the world here, name of the river, the length in kilometers, discharge in cubic meters per second, the area of the basin, and discharge per area, we put in here different rivers, and we find out that the length of the river is put in the Nile at first. We're going to talk about this a little more in a moment. It can be disputed because if we go from the Amazon itself into the other tributary rivers all the way to the very largest farther away point from in the Andes, we're going to see that the Amazon is actually larger in length than the Nile. But see, if we take into account the discharge in cubic meters per second, the Amazon River goes in an order of magnitude higher than the Nile, and very much more than any other river in the planet. So 180 cubic meters per second is a very large number of a very large volume of water. The area, obviously, is the reason why we have so much water. The capture area in a very large place where it rains a lot obviously produce much more water than places where the basin are smaller in here. So we do a rival more or less with the Congo in second place. So the Amazon first, the Congo second, and probably can actually go to the Orinoco, another river in South America, which is quite important, number 3. Missouri, Mississippi system is quite fourth in the ranking. This is an article that will come out in 2007, and a group of Brazilians geographers went to the very far point where the Amazon River starts, and they find out that it's over here in this very place called the Nevado of Mishpu. That place is the source of the Amazon. So the Amazon itself starts to be called Amazon sensu stricto here all the way to the Atlantic, but here, if we go through the Ucayali, a main tributary, and then the Urubamba, and then go to Apuribamba, reaching the Nevado of Mishmi, but that one is making it a very larger, a much larger place than the Nile. So in longitude, the Amazon is longest than the Nile. In total, this is in miles, unfortunately. Talking about 4,250 miles for the Amazon, all these considerations in account, and the contrast with the Nile, which is about 4,160 miles in the Nile. And so, according to the Brazilians, that's it. The Amazon is also the longest river in the planet. Obviously, as we mentioned, this is the basin that is capturing water ending in the Amazon. Very large. The area here is extremely large. It's in an area that happens to be in both sides of the intertropical zone, what we call ITCC, Intertropical Convergence Zone, where it rains almost all year long. We see an oscillation north and south when the seasons are moving up and down. Interestingly enough, as we see here, the Amazon is only this part in here, but if we look into this place right here, we see another basin that is coming with some other rivers, actually, not this one in here, some other rivers that are not really in account for the Amazon. So I don't remember the name of these right now, but those are another important rivers that close to the Amazon are not really even count. So it's a tropical rainforest, it rains a lot, and it's the most important river in the world. As you see here, interestingly enough, the caption of the basin is quite close to the Pacific, and yet none of the water that falls on this color area goes to the Pacific. All goes to the Atlantic. A beautiful map in here. We see here all the different rivers tributary to the Amazon. The Amazon starts more or less in Manaus. Probably Manaus, a little farther down here, and this is the Amazon itself. Then we have the Madeira, the Purus River, the Solimões, the Negro River. All those rivers are very characteristic, and we're going to actually classify them accordingly to the characteristics of the water. I see some of the rivers are really full of sediment. Some of the rivers are really loaded with organic material, and some of the rivers are rich in material from the jungle that is making a distinctive quality of the water and can be actually observed easily. So for example, here we see the Negro River and we see the Madeira River, and when these two are coming together here, the water don't really mix right away. I mean, you can actually tell what part is coming from the Negro River or what part is coming from the Madeira River, because the differences in sediment coming from each one of them. Yeah. The Negro River, in fact, Negro means black. It means the water is so loaded with organic matter from the jungle that is taking a characteristic tonality. So what we have here is a summary of the Amazon. In particular, it's important that the rains are extremely abundant, but in particular between January and June. January is summer in the southern hemisphere, and June happens to be about the time the winter starts. So that's the time where the maximum precipitation happens, and we do see flows in the Amazon River. Actually, it's an annual cycle that goes from a high level to a low level and back and forth every year happens. So the width of the river may actually go between 1.6 to 10 kilometers in the variation during the seasons, during the low water or high water. So we do have annual floods due to the seasonality of the rains. The water may actually rise up to 15 meters over the normal and go back to normal during the time, and even lower than the normal. So it's a high differences between flooding season and drought season. In places, the river is very deep. You see here about 91 meters of depth of water, and in places it's very, very shallow, but in general it's carrying a lot of water, so tend to be quite deep. In fact, the Amazon River is sometimes called the ocean river because it's possible to navigate all the way to the central part of the Amazon basin. Very much here we see Manaus. Manaus is an important city, and ocean liners can actually go through the Amazon River all the way to Manaus and use the port of Manaus to trade and take passengers and all that. So it's an important river and can be navigated quite far into the central part of central South America. Now, interestingly enough, this happens without any human improvement. The river is the way it is, there's nothing in there, there are no channels or anything, and still ocean liners can go all the way to the Manaus city. Right here, transatlantic ships is going up to 1,600 kilometers upstream the Amazon River. 3,000 tons can actually go to Iquitos, Peru, which is 3,700 kilometers from the Iquitos, right here. So it's an amazing fact. So the river is incredibly in the fact that it's having about 1,100 tributaries, 17 of which are longer than 1,000 miles. So it's a collection of rivers. The Amazon is not just a river, but it's an enormous amount of rivers coming together into one. The two most distinct ones are the Negro, I mentioned before, and the Madeira, which are very large compared with even other rivers. In fact, they are larger than the Congo River in Africa. The estuary of the Amazon is interesting in going into the Atlantic, but the fact that it's an estuary here, this is what we call an estuary, it means there's no delta. And it should be a delta because, such a big river coming with sediments from all over the Andes and everything should form a delta, and it doesn't. We're going to talk about that a moment later. So the Amazon is an incredible river. It's, as we mentioned first, it's a superlative river. In fact, during full moon, we see a tidal bore, which is a wave that goes upstream, produced by the high elevation of the sea during those times, and it can actually reach about 400 miles upstream. So it goes a wave running up, as many people go, and try to, and they do take the wave surfing upstream when the time and the conditions are right. That wave can be up to 5 meters high. So, interesting place. Now the question is, why we have so much water? And obviously, it's because rains, more than any other place. And why we have so much rain in there? I just mentioned, because we have the ITCC, which is called the Intertropical Convergence the T convergence zone. And what is that? Well, we mentioned this about several other times, and what we see is this in here. This is a map representing different temperatures in the sea. See, the black in the continents is because there are no collection over those places. But what we see here is an increase in temperature over the tropical area here, and because the high temperature in there is making the air rise, and then we do see winds moving in the direction, what we call the trace. On the trace from the north and the trace from the south, and that is part of the convergent cell that we normally call the Halley cell. So we make a cut in that section. You're going to see here this high temperature producing high evaporation. Evaporation is making the water go up because it's warm and humid, and then as they go up, eventually reaching a cold area here, we do have precipitation. So high evaporation, high precipitation, but not from just the equatorial zone or the line that moves up and down, but also from this area here all the way to just a little far south from 30 degrees north and a little far north from 30 degrees south, moving air from here and moving air from here to the central part where it rains, condensate, and rains. So in this line in here, where we see the majority of the precipitation in the planet. It's a low pressure zone, and it's the place where it rains. So these two Halley cells are responsible for that intertropical convergence zone. But as we see, this is an ideal planet in here, obviously, right? So the axis is perpendicular to the orbit, but we know that's not really true. This is actually moving around between 23 degrees to 23 degrees in here, so it's actually 23 degrees just like that, and it's producing a seasonal effect. So when we see this position here from the sun, we're going to see here summer, and we go into the other direction when the sun is in this part, you're going to see summer in the southern hemisphere. So we go summer here, the intertropical convergence line goes up, and when it's summer here and winter there, the other half of the year, we see the intertropical convergence zone moving down. And we do know that the temperature and the humidity is making the air change in density. When the air is warm, it can actually absorb more water. So, see here we have an ideal 30 degrees Celsius, and we see here the amount of water can be absorbed is larger than the previous temperatures, obviously, all the way to 40 and 50, but this is in Celsius, so you know, in excess of 30, we don't really go much of that in a permanent basis, luckily. Right here in this picture, not really a picture, it's a satellite image, what we see here represented by these clouds, this area here, see all that set of cloudy area is essentially the intertropical convergence zone. And right now we see it, the equatorial line is more or less here. It's a little farther up, but eventually it's coming down, and again, and again, and again during the year. So always go with the summer. Summer in here, it goes up. When that's the reverse, the whole thing goes down, and this is summer here. So we do see a majority of precipitation during the summer in the southern hemisphere, obviously, which is, well, as you know, the seasonal reverse. So the summer in here happens during the interval of November to March. So the rainy season for them. This is an interesting product coming from NASA, and it's measuring the global water vapor during a year in the atmosphere. And we see here the majority of the water is concentrated in these bright spots here. And see here, and then here, here. A little more complicated here, a little more complicated here, because also the continents are kind of affecting the regularity that we see over the oceans. So dark means low precipitation, and bright means high precipitation. This is a mapping mission that is measuring the tropical rainfall during the year, and it's using a precipitation radar by measuring the microwave produced and rebounded, bouncing up from the place where the humidity is higher. So using all that, we produce something like this. The rainfall is measured using this radar let me go back and clarify the tropical rainfall mapping mission. So this rainfall mapping is producing this particular information here. We see the high precipitation marked by these lines in here. See, the rain in here. It's all affected by the movement of this and the basins where the water accumulate. So, intertropical convergence zone, obviously related to the trade winds. The trade winds are formed by the terrestrial reading of the Hadley cell, this one here, and this one here. The deflection from the vertical happens because Coriolis, as you well know. So, in fact, in the tropical convergence zone, the trade winds are completely related to each other. As we mentioned before, during El Niño, we do have a change in the trade winds. So obviously, the trade winds are part of the same phenomena that's producing the tropical convergence zone, so that the rain is also affected during El Niño event. And the migration that we just mentioned here happens because we do have a tilting of the axis. This is north, and it's separated from the perpendicular to the elliptical, the orbit that we have around the sun by 23.5. That's the reason why we have the seasons. So as we see, obviously, when we have this situation here, in this point, we do have summer in the southern hemisphere, and we have this situation here. The amount of radiation happening in the northern hemisphere is maximum. So there is when we have a winter in the southern hemisphere. So summer and winter, and for us it's going to be summer and winter in the opposite eye. So this has been happening since we do have this variation in the axis. So as we saw that, now going into our subject, Latin America, what we may see the variation of the intertropical convergence zone between January, summer in the southern hemisphere, and July during summer in the northern hemisphere happens exactly like that. So the intertropical convergence zone goes from this point in here in January to this point in here in July, and back and back. So it goes up and down. Reflecting what? This is essentially making the rain moves with the line. So we go from July, where it's now raining in the north part of South America, in the area of Colombia and Venezuela. In fact, we see here another basin, which is the Orinoco River basin, is feeding the Orinoco basin during July, and then moving down in January and feeding the Amazon basin during January, and further south even so. So this area here is also seeing the rain happening in January too. So this is something we observe year over year. Now, looking into the Amazon basin here, what we see is a measure of rainfall for the year 2000. What we see here from 0 to 5,000, these are millimeters. You remember 1 millimeter is a thousandth of a meter. So right here we may actually see this is 5 meters, which is a lot, as you can imagine. So we do see a variation, and this is an estimation for the whole year. We see the maximum accumulation of rain for this happen in places like this one is here, this one is here. So in the order of 4,000 to 5,000, 3,000 millimeters, you're going to put it in meters, 3, 4, or 5 meters, total amount of rain during a whole year. So it's a lot of water, really is. This is actually, again, another mission, Gravity Recovery and Climate Experiment, GRACE, also called, measuring the amount of water in a basin by means of variation in gravity. So what we see here is during the months of March, April, and May, we see lack of precipitation and increased precipitation in the north, here, here, and here. So as we go into the summer in the southern hemisphere, we start to see precipitation, and then in October, November, December, we do see have a larger amount of water accumulating during that time. Now, I mentioned this in the beginning. The Amazon River got a lot of rain, but about 60% of the rain that is falling is rain that has been evaporated from the basin itself. So it rains, evaporates from the same basin, and rains again. So only 40% is coming from other sources. Rain in the Andes, melting of snow in the Andes and such. So only 40% is really coming from the outside and eventually ending into the Atlantic. The other part is recycled into the basin by itself. So the water budget is an interesting one, really. So the Amazon basin is in this intertropical convergence zone, and obviously is in the area defined by the two belts of the trade winds, north, as we see here, the north trade belt, and the south trades. Now we do have also another effect in here, which is quite important and interesting, is defined by the presence of the Andes, what we call orographic precipitation in the Andes. What happened here, we have the trades from the north and the trades from the south, bringing in there air that is warm and humid and goes into the basin and start raining all over the place. We see here, this is what? This precipitation in millimeters, 348. No, actually this is in inches. Anyway, so what we see is precipitation all over the place, but as soon as we reach Quito, which is in the Andes, we do see a precipitation in excess of anything that we see before. And this is produced by the elevation produced in the relief and making the winds go up and also produce precipitation right there in that place. So Quito being here, and this is quite close to Quito, we have all majority of the rain falling before reaching the highest point in the Andes. And then what? And then this. In the Pacific, is almost no rain falling on the place. And so you go to Guayaquil here, they got almost no rain ever. You go to Quito, it's much more, but to Guayaquil is very little rain. And it's produced by the precipitation of all the water before going under the elevation of the Andes. So this happens all over the place. In this case, it happened in the east part of the Andes, and if you go farther south, you go farther south where the winds are coming from the east, in this direction, you're going to see in Chile, most of the precipitation happen here, and in Patagonia, it's almost no precipitation. The orographic effect works both ways in here. But this is a very important factor. Now, what happened with El Niño? We mentioned during El Niño, La Niña, what happened. What is observed here, precipitation is during El Niño, we do see less precipitation in the Amazon. Obviously, because as we mentioned, the Niño essentially is a weakening of the trades, and because the trades are the ones bringing most of the humidity into the Amazon basin, the lack of rain is observably and very important. As we see here, an increase in the amount of rain in the east, in the west part. So we do see a departure of normal. What we normally see in the west is no rain, and we normally see in the east is a lot of rain, but now it's changing. Values are different. So the river, the Amazon River, can be traced all the way to this place in the extreme area of the Mizmi, Nevados del Mizmi, all the way to the Atlantic in that direction. But what we can observe here is all these small streams that happens to start in the Andes, and the glaciers in the Andes are coming quickly into the lower part of the Amazon basin, and taking a lot of sediment with them. So Ucayali, Urubamba, where is it, Urubamba? All those rivers are coming full of sediment, reaching the area here as a water completely full of sediment. And then they start merging with other rivers which are less abundant in sediment. In fact, we see the Marañón River coming from the other part of the Andes in the north, and when they reach into the Amazon River, they start to mix, forming the typical Amazon River. What we see here is the major rivers per percentage of contribution to the main Amazon River. So we see Marañón is supporting 5.2%, Madeira 20%. Madeira is a very important one. Let's see, Negro Branco is about 10%, and then you have Tapajos in here, 7.1, Tocantins 11%, and all these rivers are finally contributing to the major river. The nature of these waters are very different. We're going to talk about that in a moment. We mentioned that the Amazon can be considered until the Solimoes join, Rio Negro and Madeira join right here. So this is where the Amazon is really the Amazon in here. So Amazon from here all the way to the Atlantic, this point in here, and the Solimoes, Madeira, and Negro, very important rivers. Solimoes 49%, taking all the others coming from the Equatorian and Peruvian area. Madeira is coming from the Andes too, but from the farther south, and major conjunction of all the rivers. Again, another picture from the Nevado de Mismi. Here, this the melting of this ice is what is producing a tiny lake, and eventually that is forming a river that goes into forming the major one. These are the typical rivers of Peru. We see here, full of sediment and very fast. This is the river that Orellana and others got to navigate to go and find other places. In fact, we're going to see Orellana got into the river, but he couldn't get out. So, in fact, he decided that was impossible task and went all the way to the Atlantic, and eventually went back to Spain, incredible as it looks. Iquitos to Manaus, the river is changing. It's much more flat, and it's full of sediment. It's still receiving sedimentary material from the Andes until it's reaching Manaus, where it's receiving other kind of water from the Negro and other rivers I'm going to mention now. So there are many tributaries in here, and I'm going to jump into the next in here. And in fact, this is a complete map of all the rivers in here. As we mentioned before, it's about 1,100 different tributaries with names and everything. So it took a while to find out all the rivers. In fact, there are many expeditions that went through finding them and mapping them with a lot of difficulty. Obviously, this is a difficult place to be, but all the rivers are including about 7 million square kilometers of drainage. Some of the most important names in here are Amazon all the way to the ocean in here. And we're going to point out in here, the Amazon is not really making a delta. In fact, this is the continental shelf in here, the coastal area here, all the way to the Orinoco River, and this is the Amazon shelf, and then below the shelf we do see a submarine fan, but most of the sediment is carried away in this direction, north. Or right here, this is the Atlantic, right here, and this is the Amazon mouth, estuary we should call it, going finally out into the Atlantic and moving north. This water, full of mud, goes up. As we see here, it's hard to read, the picture is a little too dark, but here is another river getting together with another river in here. These two are completely different in coloration. This is the Negro River, and this is the Madeiras. So, very different nature of this one, actually, the Solimoes, Madeiras is here, sorry. But see, the nature of the waters are very different. The Rio Negro, coming from the north, the water is dark. It's clear, but actually is loaded with humic compounds from the composition of organic matter, and it's coming almost dark or transparent all the way here. When it get together with the Solimoes and later with the Madeiras, finally forming the Amazon. So, right there, even close up, you can mention this is the Negro and this is the Solimoes. They mention this is like a black coffee from the distance, obviously. Now the water coming from the Andes is beige in color. So then we mentioned some, actually put it in a map, the difference between one river and the other. So we do have muddy rivers. Muddy rivers are marked with this color in here. So all those coming from the Andes in general, north, central, and south, and even the Amazon itself is a muddy river. A lot of sediment coming from the Andes, in particular the two major ones, Solimoes and Madeira. And then what? Clear water rivers. They have no sediment. Most of them are coming from the Brazilian shale, which is here, and from the Guyana shale in here. These are clear waters and go into the Amazon. In particular, in a section where it's not really forming much of a contribution to the river, since the Amazon is already in a very important volume. So we see here sediment for the muddy rivers. Madeira is the major contributor. And then we see here these are rivers with general black water or contribution without no sediment. More than anything is humic compounds in the water. So Madeira, this is the contribution of all these rivers of black water, the Madeira, and these are the others are eventually coming into the Amazon here. So clear water rivers, and finally the black water rivers are those that are coming with a high concentration of organic compounds, and most of them are coming from the Rio Negro and some of the Guyana plateau. So those two rivers are very interesting, but in general the Amazon is like this. Where's the Amazon really? Well, everywhere, but the main course is right here. But we do see all these fluvial plain. It happened during the high season, the flood season, I should say. All this area is inundated, and there is a complex ecosystem forming here, where we have um, forests that are used to have part of the year complete flooding of the area where they live. So there is a full ecological system in this environment, like this. Rio Purus is another river of this full of sediment. And it's such a large river that they do have a particular species of dolphin, the so-called boto. Informally, the name is Inia geofrensis. Is a pink dolphin. Pink probably because the color is not really important. You know, they don't need to be protected about high amount of UV rays because the water is in the Amazon is so muddy. But they do have a high important encephalic prominence where they do rely greatly in the echolocation produced by the way all dolphins do. But these ones are even more adapted to hunt by using echolocation. They're not really very large, no more than 3 meters in length, and rather small. Tend to be appreciated by the inhabitants and giving them, you know, like always, magical powers and mythological accounts. Is natural that it happens. Another view of the Amazon River. You see, many places are actually partially flooded during the high water season. And we do have also a particular species of manatee, not just a dolphin, but a manatee. Manatees are normally adapted to live in fresh water. Dolphins are normally not, but this one is. Also about the same size, a little heavier. And they do eat only, as you know, manatees are only herbivores. They eat plenty in the Amazon River, all those aquatic plants. All these interesting large animals, anacondas and large fish, piranhas, are also coming in all these interesting movies. So you happen to be interested in these. Piranhas are fierce, especially when they happen to be trapped in places like this. You know, during the high water season, they can access everywhere, really. But when they happen to be trapped in places like this and the water goes down, they got trapped in a place without anything to eat. So if you happen to be unlucky enough to try to swim in those areas, well, you're gonna get yourself in trouble with a bunch of hungry piranhas. They are endemic into the Brazilian area. And you know, many movies have been done about piranhas, as you know. Very large exotic fish are amazing creatures in these places. I won't really spend much time in that, but you know, this is an important one. This is a measurement of the elevation of the Amazon in Manaus, in the mouth of the Negro River. What we see here? Well, this is January all the way to December, year around, and here is obviously it's a little old. Here we have a 1963. This one is 1953. Well, you see here during the January we do have a low level, and then as we go into the month of July, we start to see the increase in the height of the water. So, and then back again and up. So the increase in here happened during the portion of spring and summer, and it continues in part during the winter. And we see here, this is April, fall actually, and then it start lacking precipitation and dropping really far down. You see here a level in here. This is 1963. The level was minus, no, actually no minus, 14 meters over the local point. So we can go from 14 to 30, a total of 16 meters of difference. So we mentioned the flooded forest of the Amazon. So we do have the overflow of the river is covering about 100,000 square kilometers of forest. So everything is flooded. And we do have an ecosystem thriving in this particular situation. So plants are adapted. Some of them are actually flowering and finishing their fruit. In that time, the fruit falls into the water. Fish feed on that and then disperse the seeds anywhere the fish go. So it's an interesting system. Nowhere else is something like this. Giant water lilies, very large, obviously. You see, these things are fully adapted to live in those flooding conditions. About 2 meters in diameter is just crazy. Obviously, a very difficult place to go if you try to go walking. If you're going to explore the flooded forest, obviously you have to use some kind of flotation device. All right, well, see, here is the mouth of the river. No deltas whatsoever. What happened? Well, what happened is this delta is not really a delta, but this mouth is dominated by a current, a very strong current that goes in that direction north. So all the sediment, as you can actually see here in the picture, is moved away by the current. So no formation of a delta, it's an estuary. So we mentioned here, it's a lot of information, obviously. I'm not going to go to reading each one of these paragraphs, but since we don't have a textbook, we try to put in here all the information that is necessary. So what we're trying to show here is all this sediment is essentially being moved up north by the current coming from the south. This is the Amazon. This is Tocantins, right here. It doesn't really form part of the Amazon itself until the moment they are into the Atlantic. So Tocantins here, Amazon here, and you can tell, oops, sorry, right here, all this is water full of sediment and is going in this direction. If we look in this, is a bathymetric chart. What we see here is the coastal area, this area here, the Marajo Island, and then we do see a fan, a submarine fan, deeper than the shelf. The shelf we can actually put in here, about 200 meters or so, is the break of the shelf right here. And then the sediment extend down to 2,000 meters. But then if we see here the Amazon River coming in that direction, see the displacement in that way. So no delta, but an Amazon fan. There's another interesting picture in here representing the boundary of the fan all the way here and here. See, this is 100 kilometers, so this is about 500 kilometers by 500 kilometers or so. This is a major feature. And we do have also submarine canyons in the fan, carved by differences in the sea level during the previous times. So the Amazon fan is right here. This is being investigated by the ODP project. We have cores. The cores are actually marked by these numbers. we happen to be interested, we can actually retrieve the core information and observe what is being deposited over several thousand meters of core. So, very interesting feature, but no fans, no delta. So what happened? Where that sediment goes? Well, right here. Warren and others present a paper. This is from that paper. What we see here, that this sediment coming from the Amazon River going into this submarine fanning part is transported along the coastal area of Brazil all the way to this place in here. So in this area here, we have an accumulation into the Orinoco coast. This is the Orinoco River here. And this sediment is trapped into the Orinoco Delta. So there is a measurement in here of the sediment. In fact, in here we have a 3 by 10 to the 8th tons per year of sediment. And along the coast, obviously, some of those sediment is being dispersed into local sedimentation, but it's reaching our 1 to the 10 to the 8th tons a year of sediment coming from the Amazon into the Orinoco coast. So it's actually quite important. So it's an interesting paper. If you happen to like the subject, please talk about it. So that's all we have to say. It's much more to say about the Amazon, obviously, being such an interesting place, defining almost 2/3 of South America by their influence, and defining also one of the most important geographical areas for many ecosystems. Next time, you're going to talk about rainforest. And one of the main rainforests, or tropical rainforest, I should say, is right here in the Amazon basin. So that's all we have to say for now about the Amazon. Thank you for your time.